All right, in this problem, I have a 4-pound ball that's traveling in a circle with a radius of 3 feet at a speed of 6 feet per second. Okay, and then pull on a cable through the center at 2 feet per second, and I want to figure out once my radius gets to 2 feet, okay, what is the total speed of the ball? Okay, once that gets to 2 feet. So this is one of those central force problems where the only force acting here is the tension in the cable, which is acting towards the center of a orbit, essentially. Okay, and that's the only force. So if I sum the moments about that center point, okay, or if I think about that, there are no external moments about the center of that circle, because the only force acting on the ball is the tension, and it's always going through the center of the point. So my angular momentum is conserved for this problem. So my initial angular momentum, okay, is the mass of the ball, which is 4 pounds divided by 32.2, okay, times 6 feet per second. Again, angular impulse. So I'll take that times, that's my linear momentum. I take that times the radius, which is 3 feet. So again, mvr. Okay, or r cross mv, or however you want to think about that. Again, it's linear momentum times the distance of the circle. Okay, and then what I want to figure out is what's going on when r equals 2. So again, it's going to be the mass times its new velocity times r, and again, it's the velocity, perpendicular. That's essentially the tangential velocity, or as I have here, the transverse velocity. So again, it's the linear momentum m times v times that radius for the rotation that it's going about of 2 feet. Okay, so from this I solve my velocity, and then again this is the transverse velocity, tangential velocity. Not tangential, transverse is the proper term here, of 9 feet per second. Combining that with my radial velocity of 2 feet per second, I can get a total velocity of 9.22 feet per second. So again, recognizing I have a central force, the only force is in the tension, goes through the center, so the angular momentum about the center is conserved. So I can do that to find the transverse velocity afterwards. Then using that, combining it with that radial velocity being pulled through of 2 feet per second, I can find the total velocity using Pythagorean theorem.